Hello YouTube viewers, this is another video in this series of restoring a BMW R75/5 airhead. This is one I'm working on as a 1971 model. And I recently received a question from a subscriber, Josh. Josh apparently is restoring an R75 1972 model, pretty much the same bike. And he's asking about these multifunction switches on the handlebars, and I've cleaned these out. I've never had much luck repairing them, but I have had luck taking them apart, cleaning out the contacts, putting some silicone grease on the contacts, and it's usually that'll restore some of the movement. And this is actually a bad one that I see. This one I tried to repair it. I failed, and I basically had this in a parts box. And when Josh asked the question, I decided to dig it out and make a quick little video showing you how to take it apart, maybe how to replace some of these wires, and if possible, how to repair it. The problem with repairing these switches is you have to be really good with a soldering iron, and basically it's a plastic switch, and all the contacts sit on top of plastic. So when you try to solder these connections in here, a lot of times you'll melt the underlying plastic and you just make it even worse. But I'm going to show you how to take this apart, and I'm going to attempt to replace a wire. And I don't really mind if I destroy this switch, because it's just a spare part switch anyway. So okay, taking these apart, first you have to get the wires separated. So if it's in the sheath, you're going to have to pull these wires out of the sheath. You might not have to pull it all the way out, but it makes it much easier. You got to separate the wires. I don't know. I'm sorry for the lighting here. This is terrible, but maybe you can see there's a small circlip in there on the shaft. So you have to push in the spring. Sorry, I can't do this holding the light too, but basically you push in on the spring that lifts up that shaft, and then you pop that circlip out with I use like a little pick, like an ice pick or something. And the spring is pretty stout, and since this switch is no good anyway, I'm going to go ahead and use a pair of channel pliers. If this is a good switch, or if you want to save the switch, of course, you could probably still use the pliers, but just wrap them in something so you don't damage the plastic too much. Again, you just push down on that, pull that circlip out. It's usually not that easy, but this circlip is, I think I've taken this thing apart about a dozen times. That circlip is pretty shy. It's also apparently magnetic. But and then it comes apart. It's basically a plate there, and this plate is pretty stout. It has 3 contacts, and they ride in these depressions. The spring is pushing down on there, and as this slides, yeah, I have to get better lighting. Anyway, hopefully you can see this plate slides in, and it falls in these contacts. These contacts have little holes, which actually the wires go through these holes, and they're soldered in there, but they're not. The wires don't come up enough to make a flat surface there. They're indented, so this plate can basically pop in those indentions. And over many years of this plate sliding back and forth, many left, right turns, these contacts just get worn out. This one was especially worn out. Right here you can almost see where those two contacts are supposed to be connected, but the connection, that indention just sat on there, and over many years just broke that connection. And I tried to build up that area with my soldering iron and some solder, but as soon as I hit it with my soldering iron, the plastic melted and it just made it even worse. So this switch is pretty much shot. I'm gonna try and solder a new wire in one of these and see how easy it is to solder. I haven't ever actually done that, so I'm gonna give that a shot, see how easy it is to just replace a wire. If your switch is good, the contacts are good, but maybe your wire is bad. I'm gonna try and do that now. See if it's possible or how easy it is to do it. Okay, first thing I'm going to do is try and remove one of these wires. I'm going to try and get this yellow wire out. It's connected to that one right there. Got my little soldering rig set up. These are amazing when soldering. I think they're like $3 at Harbor Freight or something. And so okay, I was able to get the wire out, but you can see where I melted some of the plastic around the contact there. Just heating up that plate. Looks like it can still be sanded down, but I'm going to keep going. That looks fine. Okay. I'm going to try inserting a new wire. So if you try this, you're going to need to twist the wire pretty tight. And whenever I solder, I like to use a lot of flux. It just helps the solder sink in better. And most solders is our rosin core solder that you don't have the separate flux. The flux is actually inside the core of the wire, soldering wire. So again, let's use the trusty. plenty of YouTube videos out there about how to solder, but beginning people just starting to do it sometimes think you just like drip the solder on the wire. You don't do that. You just heat the wire up and then use the wire to melt the solder. You want the solder to sink into the wire. Okay, next I'll attempt to insert the new wire. Okay, once you get the old wire out, there's going to be some old solder, maybe even some old copper strand stuck in there that's going to basically not allow the new wire to even go in there very much. So I'm going to use a small drill bit here. Solder is actually really soft and it should be easy to dig out. Yep, that looks good. Okay. That seemed to work good. That's a 1/16 drill bit that I used to clean that little hole out. And I'm going to use my little clamp here to try and insert this wire. And again, I'm using quite a bit of flux because I don't want to get the plastic too hot. I want this. I want to go on pretty easy. Now you need to leave a indentation, so you don't want to stick the wire all the way through the hole. You don't want it flush. You don't want it all the way through, you don't want it flush, you want to indent it about. There's a couple of millimeters there for this plate to ride in and basically fall in the little indentation. Okay, that's in there. It's I had to add a little solder to flow down in there around the wire, which is going to close up that indentation, but I think as long as it's just solder and not the copper wire, you can use a drill bit to basically hollow that back out. And I'm going to go ahead and just going to go ahead and add more solder, because if I have to drill that indentation out, I want the drill to ride in the center. I want the drill to well, that's in there pretty good. I can even see the solder coming around the wire in the back, but basically that's going to take my Dremel to first flatten it out on top, and then a drill bit to make the indentation for the plate here. Okay, after looking pretty closely at my soldering job here, I can pretty much say that this is a perfect example of what not to do. It's consistent with my previous attempts to repair the switch using a soldering iron. The heat that I used to both release the old wire, remove the old wire from the switch, and then solder in the new wire just heated the contact up too much, and the whole contact just kind of sunk down into the plastic. The plastic just is not made to resist that much heat, and it really just does more damage than repair. So I'm thinking just using a soldering iron on this contact area just doesn't work. Okay, I'm going to try something a little different here. Trying to solder from the top. Just left a big bulge that needs fixed. I'm just going to try soldering it from the back. This you can see it, even a couple of millimeters indentation. Okay, soldering from the back worked much better. Because you're focusing the heat on the bottom of the switch, you don't really damage, and that's the contact area that I soldered to. you don't damage the top of the rivet or the plastic underneath the contact area. The only difficulty was you have to leave enough copper wire. You basically have to cut the insulation back, leave about a maybe eighth to quarter of an inch of copper wire exposed, because you can't get enough heat from your iron on the bottom of that rivet. You have to basically first tin the copper wire like I showed before, and then put your iron right directly on the wire and add more solder, and the solder will flow down in there and make the connection. So that's a pretty solid connection. I tested it with my meter and it's good. The only problem with doing it that way is you're going to leave that much of a bare connection, and if you do all those wires, when you put these wires back on the handlebars, put the switch together, these wires have to bend, and you don't want them shorting out. So if you do this, you're going to leave some bare contact. I would use like some liquid electrical tape on those connections just to keep them from shorting against each other. But that's the only way I see to use a soldering iron and solder to insert new wires directly on the switch here. Okay, in conclusion here, the best way it appears to solder a new wire on these switches is do not do what I did at first. Don't use any heat on the top of this switch. This plastic is not resistive to heat, and it will melt. And I've done it twice here on this same switch. I've used a soldering iron on the top, and it just melted the plastic underneath and just damaged the whole top of the rivet here. It sunk down in there, and it'll just make the connection worse. The best way to replace these wires, if the connections are good, are to come down a couple inches, cut the wire, and just solder in new wires down here somewhere. If you have to replace the wires in your switch, the best thing to do would be to just drill out the old wires, go in on the top of these rivets, and using a drill, this is a 1/16 inch drill bit, just slowly drill the wire out from the top using pretty slow speed on a drill, because again, you don't want to build up too much heat. And then take your new wire, cut maybe a 1/2 inch of insulation off the wire, twist the wire really tight, go ahead and tin the wire like you saw me do earlier in this video, and then just solder the new wire in from the back, leaving enough bare copper wire to get your soldering iron on, and then add a little solder. It'll flow down in there and make the connection, and you'll be good to go. You would then need to insulate these connections with some liquid electrical tape, but I think that would work fine. It'd be really cheap, and you'd be able to replace all your wires. If your rivets are damaged, if these contacts are just worn out, the only way I can think of to repair these contacts on these rivets would be, there's some cold solder epoxies out there now that are very conductive, and epoxy is usually an insulator, but they basically mix this epoxy with silver powder. Silver is a very conductive metal. I think it's the most conductive metal. It's more conductive than copper. But by mixing the silver powder in with the epoxy, they basically make an epoxy that's very conductive, and it can be used in stuff like this that you can't use the heat of a soldering gun, a soldering iron. The problem with the silver epoxy is it's very expensive. I called around, and the cheapest price I could find the stuff was like 15 grams in a syringe for like $60. And it then becomes a cost-benefit question. Last time I bought one of these switches, I paid $90. So $60 for a small little syringe of specialty epoxy. It's you throw in shipping and handling, or just driving to pick the stuff up. It becomes kind of it would be worth it if you had a lot of electronic products. You could also use the epoxy on a lot of other uses for that specialty epoxy. I like to use soldering, so it's very rare that I can't use soldering on something. So it's just not worth it to me to buy the epoxy. But honestly, I think it would work good. You could actually use that epoxy to both epoxy the wires on the switch, and you can use the epoxy to build up these contacts, and then once the epoxy's set up, maybe use a Dremel and sand the contact down really flat, and then use a drill to recreate the divots. And I think your switch would then work great. I've never used it before, so I can't give you any personal experience, but I talked to a guy who supposedly is an expert on those epoxies, and he said it would work great. But then again, I don't know. So that's pretty much it for cleaning and repairing this switch. Next, I'll just show how to put the switch back together, and this video will be done. Okay, putting this switch back together is easy. Just it's especially easy if you mark. There's two bolt holes on the top and bottom that the switch sits in its housing. It's before you take it apart, if you mark which bolt hole is on top, it just makes it much easier, because you know the thumb switch is going to point towards your thumb. So if you know that's up, then you know your switch is going to go on like that. And this plate that fits in the switch, it sits on top of that spring, and basically it has three little protrusions where it folds back down. It folds down. It's hard to see, but it fits into three little slots. There's one on either side there, that actual thumb switch, and one at the very top. So it goes, and again, this is the left hand headlight switch. This is not the right hand ignition switch. So it fits down in there, and then that goes on top of that, and then I'm not going to put this thing together. It's pretty much shot, but get the picture. Then you just push it back down in and snap your little circlip back in there, and you should be ready to go. Yeah, I hope this video had some use to anybody out there working on this switch. Again, these switches they're not very conducive to repair. Cleaning them is easy. A lot of times just cleaning them will bring back a lot of the function. But if they're damaged, it's going to be tough. So good luck to all. Goodbye for now.